Good morning, everyone. Welcome to 1.3 Surface Area. Let's begin. Surface area is defined as the sum of all areas of the faces of an object. So here we are going to be dealing with three-dimensional shapes, and we are going to be adding up the sum of all of the sides of these shapes. Okay. The first thing to understand is can be explained by these three diagrams here. So we've got figure number 1 here, which is a full complete rectangular prism. Diagram number 2 has a small piece cut out, and diagram number 3 has an entire section of that right side missing. So the question is, how do the surface areas of these shapes compare? Let's say, for the sake of argument, let's say the surface area of number 1 is 50 centimeters squared. Okay? Now what about diagram number 2? Well, at first glance, the surface area of number 2 should be different. It should be less than figure number 1, right? Because it has a piece missing. But if you look at it a little bit closer, here's what we see. If we look at the top of diagram number 1, we've got a full red piece colored in. Well, diagram number 2 has got this piece right here, but it also has another piece on the top that's top facing, which is right here. So if we were to put these two pieces together, we would have the same complete top. Same with the front. The front here is a full solid section of blue, and at first glance, this one appears to be less surface area, but we have another piece of the front right here. If you put those together, they would still calculate to be the same as diagram number 1. And finally, with the right side, we've got a piece like that, a full complete piece. Here, we've got the same amount, it's just broken into 2 separate pieces. So the diagrams, the surface area of these 2 shapes is exactly the same. Okay? Number 1, do that in black here. Number 1 and number 2 are equal in surface area. Okay? Well, what about diagram number 3? How does it compare? Well, the tops may be the same. If we look at the front and back of it, we've got this blue piece here, but we have something missing, right? There's nothing else to add to the front of this blue shape, of the front here, of this third figure. So 3 is less than 1 and 2. Okay? So if there's just a small section cut out, that doesn't affect the overall surface area, but if there's an entire chunk missing, that does. Okay? People sometimes get these wrong because they go too quickly and they think, oh, well, you could put less into number 2 than number 1, so it must have a smaller surface area. But this isn't a question of volume. Volume, if we were filling up the shape, then yes, number 1 would have more than 2 and 3, but that's not what we're asking. We're asking, what's the surface area? What's the total exposed area around the outside? And number 1 and 2 are the same, and 3 is less than those. So here's the question where we have to calculate. Okay, we're given this three-dimensional shape with just one small section cut out. So the way to calculate these that I find is the best is to calculate the top and bottom as they are the same, the front and back, and the left and right. When you've calculated those 6 faces, you're going to add them all together, and that will give you the surface area of your shape. So the top is labeled here 20 by 24. So this is 20 by 24. So I would go 20 times 24, and because I want the top and the bottom, I'm going to take that number and I'm going to multiply it by 2, because I want both the top and the bottom of the shape. This would be 960. The front and back is 15 by 20. Get these guys off here. 15 by 20. So that's 15 times 20. We want the front and the back, so we're going to go times 2. 15 times 20 times 2 is 600. And finally, the left and right, excuse me, is 24 by 15. So we're going to go 24 times 15 times 2. 24 times 15 times 2 is 720. Once we've got these three numbers here, we're going to add them all together. 960 plus 600 plus 720 is 2,280 centimeters squared, is the surface area of our first shape. There are a number of formulas here, and on any test or quiz or final exam, you would always have the formulas available to you, so you never have to memorize them, okay? So just keep this as a reference page. We're not going to do any like on these right now. You've got some coming up right here. So the first one is a can of tomato soup, and we are asked to find the surface area. Well, this shape is a cylinder, so the formula is 2 pi r squared plus 2 pi rh. We plug in our values. R is the radius, which is 5, so 2 times pi times 5 squared, plus 2 times pi times r, which is 5, times the height, which is 14. So 5 squared would be 25, and I go 25 times 2 times pi. I should be getting 157.08 over here. And on this one, 2 times pi times 5 times 14 is 439.82. And then finally we add those together. Is 596.9 is the surface area of this cylinder. At this point, I'm going to give you a cylinder of your own. Pardon my somewhat messy drawing. I'll give you a radius of 7 and a height of 11. So the formula is 2 pi r squared plus 2 pi rh. The radius is 7 and the height is 11. So please take a moment, pause the video, try to find the surface area. Now that you've had a chance to try, let's look at the answer. So it should be 2 pi 7 squared plus 2 pi 7 times 11. So 49 times pi times 2 is 307.88 plus 2 times pi times 7 times 11 is 483.81. Add those together. 791.69. All right, now let's try one. Actually, I'll get you to try this one on your own here. This is the surface area of a rectangular prism of a juice box. So I want you to find the front and back of this shape, the left and right, and the top and bottom. Find those three numbers and add them together, and you'll have the surface area of this juice box. So please pause now and give that a try. All right, let's look at the answer. So the front and back, if we're calling, I call this the front here. So this is 8 times 14 times 2. 8 times 14 times 2 should be 224. The left and right is right here. That's 14 times 5 times 2. 14 times 5 times 2 is 140. And the top and bottom, obviously up here, is 8 times 5 times 2, which is 80. Add those together. 80 plus 140 plus 224 is 444 centimeters squared. Okay. All right, here's another one to try. We won't worry about part B, but give that another try finding the rectangular, the surface area of this prism. So once again, you want the front and back, left and right, and top and bottom. So please pause and give that a try. Here's our answer. 6 times 5 times 2 is 60. Left and right is 10 times 6 times 2 is 120. And top and bottom is 10 times 5 times 2 is 100. We add those up and get 280 centimeters squared. Hopefully you got the same answer. Now, here's one that sometimes gives students trouble. It says Sylvia wants to cover the stairs of his basement. There are 14 treads or steps. So there's 14 steps marked in black there. And there's also 14 risers, which is this part right here, marked in red. Each step is 90 centimeters wide and 24 centimeters deep. Each riser is 90 centimeters wide and 18 centimeters high. We want to know the surface area of the treads, of the steps, the surface area of the risers, and the total surface area he has to cover. So I've got steps and risers. The steps are 90 times 24, and we are told there is 14 steps, so we're going to times that by 14. 90 times 24 times 14 is 30,240, and the risers are 90 by 18, and there's 14 of those. 90 times 18 times 14 is 22,680. If we add those together, 52,920 centimeters squared. It's our answer. The one other type of question you can get here is you can see on this one, they don't give you the measurements of the sides, but what they do give you is they tell you they're all constructed from centimeter cubes. So a centimeter cube has a length, width, and a height of 1. So when I'm confronted with a question like this, I ask myself, what is the surface area of one of these faces? And if they're each centimeter cubes, the area of this one face is 1 times 1 is 1. The area of each face is 1. Now all I have to do is count the faces. So if I'm counting the front, I've got 1, 2, 3, 4, 5, 6. And then I've got 6 on the back, so I have 12 times the area of 1, right? Each area of each face is 1, so there's 12 centimeters squared from the front. For the left and right, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. Oh, sorry. And then there's 20 on the right side as well, so that's 40 times 1 equals 40. And the top and bottom, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's 10 on the bottom, so that is 20 times 1 equals 20. We add those all up, and we get a surface area of 72 centimeters squared. So if they do not give you the dimensions, the lengths, it's likely a question that involves centimeter cubes, so you're going to want to find the surface area of one of those faces, and then you're just counting the faces. All right, that brings us to the end of 1.3. I'm going to give you a couple questions to try from the textbook. If you go to page 32, you can do numbers 4, number 7, number 8, 10A, and that's good. So 4, 7, 8, and 10A. There also will be on Teams, on the Files page, there is a 1.3 extra practice version 2, and that will give you some additional practice with surface area. And that brings us to the end. Don't forget to like and subscribe. We will have our test coming up in the next day or so, so make sure you stay on top of this. Thank you. Have a good day.